Good morning. Yesterday we discussed how to find slope from a graph and we discussed some characteristics of it. Quick review. The slope is the steepness of a line, and the way we calculate it is the ratio of the change in the vertical distance divided by the change in the horizontal distance. Now, if a line segment rises from the left to the right, so that would be a graph that sort of looks like this. We say that line has a positive slope. It's increasing as we go to the right. Now, if a line segment has falls from the left to the right, that'd be a graph that looks like this. That would be a line with a negative slope. Okay. If we have a horizontal line, now a horizontal line would be going left to right. That has a zero slope. And vertical lines, which would be graph going straight up and down, has an undefined slope because we're dividing by zero here. There's no change in your run. Okay. So in today's lesson, we are going to be looking at how can we calculate slope, not from a graph, but using a formula and some calculations. All right. So let's start off with what we did last day. We have a graph, a graph here with a whole bunch of different lines on here, and my first task here is for the line AB here, determine the slope. So what we did last day is we took 2 points on the line. It didn't have to be the end points, right? But we take 2 points on the line and we see how much does it change in the y direction and how much does it change in the x direction. So in the y direction, we are going up 1, 2, 3. So our rise is 3. 3 up is a positive, right? And if it went down, it would have been a negative. And our run is 1, 2, 3, 4, 5, 6. So our slope of the line AB is our rise over run, which is equal to 3 over 6. And that simplifies down to a half. Okay. Now it's going to be important in the next unit that you always simplify your fractions. In the next chapter, the next lesson, we'll be looking at parallel and slope lines. So you need to compare slopes. So it's easy to do that if they are all in the lowest terms. Now, the focus of this lesson is to calculate slope, right? And essentially what we're going to do is put a formula to what we just did here on the graph, right? So what we did is we found the rise. What is the rise? The rise is the change in the y direction. And you may remember the little triangle from science class. The delta triangle here represents change. And then we divided by the run, which was the change in the x direction. So the slope of a line is equal to your rise over your run. And your rise is your change in your y direction divided by your change in your x direction. Okay. And just as we do in science, how do we calculate anything that changes? We take the final minus the initial. So the final position minus your initial position. So if we're saying we're starting at A, we're ending at B, we take the final position, which is B, subtract it from A. So the change in Y would be our y final position, so I'll do y with the subscript b, subtracted from our a initial position, divided by our change in x, our x final position, which is b, subtracted from our x initial position, which is a. Right? So in order to execute this formula, we need to know what the coordinates are. So we know what the x and y positions are. So A is at, the x position is 1 and the y position is 8. And B, we're at 6, 7 in the x position and 11 on the y position. So to calculate the slope of the line AB by using the formula, it will be our YB minus our YA divided by our XB subtracted from our XA. Okay? So we go, our YB value is 11 and our YA value is 8, so we go 11 minus 8 divided by our change in our x position. So our xb position is 7 and our a value is 1, so we go 7 minus 1. Then we just clean this up. So 11 minus 8 on the top is 3. 7 minus 1 on the bottom is 6, which is equal to a half. The same as what we had before. And that's important, right? So a word of caution here. The common error that student makes with using the slope formula is they will mix up the order of the a and b values. So on the top they'll go b minus a, on the bottom they may go a minus b. That will lead to an incorrect result, right? Usually a negative difference of a negative sign, right? Or they may put the x values on top and the y values on the bottom. So those are some things to pay attention to. So I'd like for you to practice this, right? For question G here, find the slope of line CD and EF. So you need to first determine what the coordinates are of each of these points, then apply the slope formula. So pause the video, give that a try. So the first step was to determine the coordinates of each of the points. So C is at 2, 5, D is at 6, 2, E is at 9, 3, and F is at 12, 12. All right. So to determine the slope of C and D, hopefully, and E and F, you executed it by using the slope formula. You take the second point, subtract it from the first point, right? So the slope of CD is YD minus YC, divided by XD minus XC, okay? Which is equal to 2 minus 5 divided by 6 minus 2, which is equal to negative 3/4. Now, if you did the slope of DC, you'd still end up with the right answer. So don't worry about that, but you need to stay consistent. So in this case, you go the value of C subtracted from the value of D. So you need to just be consistent with the way you do your calculations. It would have been 5 minus 2 divided by 2 minus 6 would have given us, once again, negative 3/4. But you need to be consistent with the order you put the points in. So using the same strategy, the slope of EF becomes 9 over 3, which is equal to 3. Okay. So the equation for slope, the slope formula, is your y value of your second point subtracted by the y value of your first point divided by your x value of your second point divided by the x value of your first point. Right? Or another notation is you can use the point notation, which is saying the exact same thing. So the same point 1 and 2, you use the actual letters of the points, Q and P. You might find that a little bit more clear. Just it doesn't matter, whatever you prefer. Okay. So in the next question, instead of reading points off of a graph, we're given coordinates G and H here with the values and asked to find the slope of G and H. Right? So we take the y values of the second point, subtract it, so minus the x value, sorry, the y value of the first point, divided by the x value of the second point, subtracted by the x value of the first point, which is -3. So put that in brackets. This is another common error sometimes students come across, is the double negative. Right? So we have on the top -2 minus -8, which becomes -10. In the denominator, we have 7 plus 3. These two come together, make a plus sign, which gives us 10 in the denominator. So -10 over 10 is equal to 1. All right. So the last question that we're going to do together here for this lesson is example number 2. Okay. So example number 2, we have 3 different students working here, Eleanor, Bonnie, and Carl. They all find the slope of the line between the points E and F. As you can see, they all come up with different answers. So there's some mistakes being made. So at least 2 mistakes here, right? So I'd like for you to work through these calculations and find out what error did the students make. So pause the video and try to determine what error did the students make. Hopefully you noticed that all 3 made some sort of mistake. Eleanor used run over rise instead of rise over run. Right? So you x values divided by y values. Bonnie was not consistent with her coordinates. She used E as her first point down over here and E as her other point over here, so she was not consistent. You always go the same order. And Carl made a transposition error here, so he used -10 instead of 10. Okay, so that is it for this lesson. So try the homework questions. They're posted on the website, and I do have them up here as well. So give the homework questions a try, and I'll see you soon.